Okay, so I know I said to you about not drawing a pie chart, but let me just visualize this to help you visualize. So, what they're saying is that one piece of 34 degrees, let's say it's roughly like that, right? So 34 degrees. That slice is worth 136 students. So we know that there is a bigger piece there left, all right, and that makes up the 360 degrees, and it will also make up a certain number of students. So you've got to try and figure out, well, first, how many degrees is left. Do you know how many degrees is left? 326 degrees. All right. So somehow you've got to solve the problem. 34 degrees equals 136 students. So how many students does 326 degrees equal? There's the mathematical issue you've got to try and solve, however you want to do it. Okay. So before I tell you, right, maybe you can have a go at solving that problem for yourself. Okay. So guys, what's your thought process? Let's pull some ideas. What could we do?
We could find out 1 degree how many students are.
I'd say that was a very good idea. Whether it works or not, I'd say it's worth trying, and we'll see whether it does work. So, what is 1 degree then? How do you figure that one out? So if 34 degrees is 136 students, what have you got to do? Yeah, by? What by what?
I got it.
So I've got to do share 136 students by 34 degrees. Now figure out how many students goes with each degree.
4.
So it's 4. So 1 degree is 4 students. So there's a useful thing.
Okay.
So 1 degree is 4 students. So now what do I do? Alright, how? What would you do from that point?
47 times.
So you do 4 times. No.
360.
No, you do 4 divided by 336.
So what the question is, sorry, Rosa, how many students watch television for, so we've got 47 degrees, the first question, okay, 47 degrees is for watching television. So then they say, what is the number of students for that? So if 1 degree is 4 students, we do
47 times
47 times 4. And we get the answer, 188.
And that's the answer.
188 students, yeah. Okay. Then it says, if 38 students visit friends, what angle would it be? Okay, so they've changed it slightly. So now we've got to work the other way. Instead of there's the angle, I want to know, well, 38 students, okay, equals what angle? So how do we do that? Well, I'll tell you what, I'm going to let you a couple more minutes to think about it and then we'll come back. Okay, so, go on then, what's your idea?
48 degrees.
Well, how do you work it out though? I want to know how you work it out.
Wait. 38 students.
Yeah?
It's not the same exercise, is it?
It's the same question, yeah. If 38 students visit friends, what angle would it represent? So we know that 34 degrees is 136 students. Now the thing is, if it's only 38 students, what do we know? It's got to be less than 34 degrees. Quite a bit less, hasn't it? Okay, we've just got to figure out what that angle is. Andrew, what do you reckon?
It can be just 38 divided by 4.
38 divided by 4, because that'll tell me how many lots of 1 degree, I guess, right? Yeah? Okay, so if I do 38 divided by 4, what do I get?
9.5.
9.5. Okay, so there's 9.5 lots of 4 in 38, so that means there must be 9.5 lots of 1 degree. So it's 9.5 degrees. Okay, good. So we've used that piece of information that you did at the beginning was very useful. And then, how many students were used in the sample in total? So what is the total number of students? So I think, again, we can go back to this piece of information. The total number of students will be, well, we know, again, 1 degree is 4 students, because that was what we were told at the beginning. We worked it out. So how do we figure out how many students were there in total?
Do we do 4 times 360?
I'd say so. 4 times 360 degrees. And that is? 1,400. So 1,440 students. 1440, yeah. Shortcutting it. Okay? Make sense? Make sense with pie charts? Alright, so I think that was quite a good question. That doesn't get much different from that. Obviously, we could look at, well, how do you actually draw the pie chart after that? But I'm sure you know how to measure angles. And it's all about calculating the angles to start with. So, that leads us on to today's objective. Alright? So, today's objective is to construct and read values from a stem and leaf plot. Okay, so that's what we're going to talk today. So to be able to do that, you need to understand what a stem and leaf diagram is. You need to be able to read values from it, and then you need to be able to construct one, okay, from a set of data. So first thing we're going to do is let's read a stem and leaf diagram. Okay, let's have a look at how we do it. So what we're going to do is, looking at example 4, all right, on page 114, okay, we're going to go through how that is what it is, okay. So we've got a list of those numbers. Can I get you, please, I know the stem and leaf diagrams are there, but can I get you, please, to write out the numbers in the list so that we can do it ourselves, okay. So we're looking at example 4. No, let me just check. It's example 5 for you. Example 5. On page 145. Okay? So write out those numbers. And I'll do the same. Okay, guys, so we've got this list of numbers. Now, what we're going to do is going to talk about what we need to do with these numbers. Okay, so that's quite important. So, I've asked you to write them down because I want you to be able to cross off the list as we're going, go through the actual process. I haven't asked you to draw the stem and leaf diagram that's in the example because we're going to do that now to understand what it is we need to do. So we've got a list of numbers. Now, with a list of numbers, this set of numbers doesn't actually mean anything at the moment. There's no particular values that we can analyse. But what we tend to do with sets of numbers is put them into order. Right? We want to know what's called the distribution of the data and how the numbers are spread out. Do we have a certain number of one type of number? If we look at a particular range of numbers, is there more in that? So for instance, if these were test scores, we would want to do a bit of analysis and see whether in general do we understand or not, or that kind of thing. So a stem and leaf diagram is a way of organising our data so that we can then understand and analyse it better. All right? So we want to make things nice and tidy and still be able to see things. So, a stem and leaf diagram. Now, a stem and leaf diagram has two parts. All right? It has this line which separates the stem from the leaves. Okay? So can I just get you to stay with me, listen to me a minute. You'll be able to write it down in a minute. You know it's there in front of you on the book, so you don't need to write while I'm talking. You'll understand. So we have a stem and we have a leaf. Now, the reason is a stem is a way for you to write down the thing that appears in all the numbers. Okay? So, in this case, the stem that I'm looking at is all my numbers have tens and units. Okay? So, which is the smallest number I have out of that list, can you see? So I've got 17, anything less than 17? 16, okay, there's a 16, that's my smallest. What's my largest number?
38, 39.
No, 44.
We've got 42, 44.
44.
That's the largest we reckon. Okay, so here's the thing. So my number, my stem and leaf diagram has to go anywhere between 16 and 44. Now, when I said the stem is about the thing that's repeated, it's because there might be lots of numbers in the 20s, lots of numbers in the 30s, lots of numbers, and I kind of don't want to have to keep writing 21, 21, right? There's no need. So my stem, in this case, represents my tens. So I've decided that this part represents my tens. And then the leaves part represents the units. Now what I should always do with a stem and leaf diagram is write that down. So I'm going to pick a number, so I pick this one and just write 3 line, the line represents this line, 8 equals 38. That's what it means. Alright? So now in my stem, I need to write down all the tens that I have. So the lowest value of tens I have is 1. 1 being 16 and 17. And I don't have anything less than 10. I do have some 10s, I have some 20s, I have some 30s, and I have some 40s. Do I need to go any higher than the 40s? No.
No.
So I've done that by looking at my minimum value and my maximum value. I've identified that. Now what I've got to do is put these numbers in my table. Now here's the thing. Quite a lot of people want to jump straight to the finished thing, but it takes them longer. Now my tip for a stem and leaf diagram is you're always going to do it twice when you draw a stem and leaf diagram from scratch. First thing you do is not in order, and then you rearrange it. And what I mean by that is I'm now going to go through each number in turn. I'm just going to put it in the right place. So 25, I'm going to cross it off. I'm going to put a 5 next to the 2. Alright? 38, I'm going to put an 8. Now, one thing that must happen, now you don't need to draw these lines, but numbers must be lined up. Okay? The next number is 17, so I write a 7 for 17. Now, here's the interesting bit. I've then got to do 33. What do I do for 33?
You do it next to the 8.
Good. I just put a 3 next to the 8. Okay? So I know that that 3 is not a 3, it's a 33. Okay? And we're going to go through and put all those numbers in that one. Not trying to put these in order, they just go one number after the next, just put them in. Okay? Can I get you to do that now? Go for it. And I'll do the same thing. Right, what we've got. Hang on, let me stop. Right, what you okay, so this is my point. When you've done it all not in order, then all you have to do is put these lines in order, which makes it really easy. So I just go through my ones and do, well, it's 6, 7, 7.
Ah, okay.
This line will be 0, 2, 4, 5, 6, and 8. It makes it a lot easier to put them all. We've got, when it gets longer, it gets a bit harder. I might have to cross 0, 1, 2, 2 3s, 3 and 3, 3 and 3, then 5, 7, 8, 5, 7, 8, 9, and then finally, nice and easy, 2 and 4. Okay? So now I've got a stem and leaf diagram in order. And the important thing is, again, that each set of numbers is lined up. Now this is important because I can now make some kind of conclusions about the what's called the distribution of the data. So if I said to you, comment on what numbers we have, what kind of comments would you make? Anything that you can think of. What kind of comments would you have? So let's say they are test scores. Let's say we've got a test out of 50. What would your conclusions be about the people's test scores? Anything you can do. Can Why would you say pretty good? Pardon? But what's your reasoning? If you're looking at that saying they're pretty good, what's your reasoning for that?
What do you mean test out of 50?
So there's a maximum score of 50, say.
Pretty bad.
You think pretty bad. Kim thinks pretty good. You might both be right, but what's your reason? Out of 50.
It's kind of
You think why?
Because the numbers
because they're
are
really
low.
low scores.
And what makes you say that?
Because there's like
Because
1, 2, 3, 4.
because you can
There's
see-
maximum is 9.
because you can see 60.
What's the maximum score?
45.
44, not 9. There you go, you see.
Okay, then
Which, Goni, what were you going to say?
Well, actually, if it's out of 50, they're pretty mediocre due to the third column, which is the middle one, being the largest.
Okay, so if I were to add a 5, we haven't got any 50s. But yeah, I mean, actually, that's the thing we're looking at. And because we've drawn it in such a way, we can say that the most common score in general was somewhere in the, what? In the 30s. But if we say in the 30s was like a normal score, did people then tend to get more than in the 30s or less than 30? And they're not going to get that.
More.
Less, because the next highest group is in the 20s. Okay? How many people got into the 40s?
so I was right. It's pretty
It's
bad.
only 2. So you could say mediocre towards bad. Now the one thing I just want to make aware of, because we've done the numbers like this, if I were to draw these, just highlight over these numbers, okay, if I do that, what does it now look like?
A bar chart.
Callista?
A sideways bar.
Yeah, a horizontal bar chart. It looks like a bar chart. Now, the only reason it looks like a bar chart, yes, I'm sticking your head to the side. The only reason it looks like a bar chart is because we've kept the numbers in order. Yeah, we've laid them out, so we can use that piece of information. All right. So it's quite useful in that way. Alright? So, if I asked you certain questions about this, for instance, okay? If I said to you, what was the minimum score from that stem and leaf diagram, where would you look? 16. So there's the minimum. Minimum is 16. The
highest is
maximum
44.
would be 44 at this end of the stem and leaf diagram. Right, here's a question then, see whether you remember. One of the averages is the median.
33.
What's the median? How do you find the median of a set?
I know.
Go on.
You cross them like first you cross.
Because you're
the
trying to
two,
find the what?
the median.
But what is
The
the
middle
median?
one.
The middle value,
So
okay.
you do 2, cross 2 out, then you cross 7, then you cross 8, 9.
Okay, that's one way to do it. You can do from 4, the minimum, maximum, and then go in like that, can't you? Now, where do I cross after 2? The 9. So the next highest is that one, and I can do that way if I like. I can cross. That's a very simplistic way of finding the middle. So let's do it.
It's 0.
Well, I've got lost because I can't remember whether.
I started in 7.
So, how many numbers have I got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20.
You need to stop in 10.
So, which is the middle
1,
number?
2, 3, 4, 5, 6, 7.
Which number though? The which number?
It's 0. It's right.
Why is it 0?
Because it's the number 10.
Ah, but is 10, is the 10th number, Igor, the middle number?
No.
Why?
Oh, 30.
Because
Oh
it's
my God.
still 10th number, it's like still not in the middle.
What's in the middle
30.
of 20 numbers?
30.
It's in,
Which number is in the middle of 20 numbers? It's not the 10th, is it?
It's the
What are
line.
you doing? You're taking 20 numbers and splitting it into 2, yeah?
Yes.
And that leaves me with 10 numbers and 10 numbers.
Oh.
So the 10th number is not in the middle.
there's no middle.
There's no middle number. You're right, because we've got a 10th and a 10th, okay? 10th number and the 11th number. So what we do in that case
you do both.
is we find the middle of those two numbers. So what we've got here, okay, is two numbers. So we, just to check, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there is no middle number, but 30 and 31 are in there. So we've got to find halfway between those two numbers. So what's halfway between those two numbers?
15 and
What's halfway between 30 and 31? 30.5. So 30.5 is the median value. Okay. You think you understand?
But how do you cross them out?
I think actually it's quite difficult to actually cross out properly. I'm going to rub other things out now if I'm not careful. Yeah, if what I do when you cross them out, if you have them in a line like this up top, you know, if I have them like this, what do you do to cross them out? You would start with the first one and then go to the last one. Start with the next one, then go to the next one. Okay? Start with that one, then go to that. If they were in order, we have to. So you've kind of got to do that with the stem and leaf diagram. So we start with the smallest and go to the largest. Then go to the second smallest and go to the second largest. Third smallest, third largest. Fourth smallest, fourth largest, and so on. So I keep going up, backwards and forwards like that, right, until, so if I remember I've started with this side, until I'm left, where is it, if I cross both of them out, I know I've got a problem. So I leave the last two, and find the middle. Now, if I've crossed them out and I can get left with one number on its own, fine. I'm happy with that. Right, I've got a bit of a mess in my diagram now. But I've got one more question for you. Okay? What percentage of people scored more than 25 out of 50?
I know. You do 25 divided by.
No, hang on. Careful.
Wait,
So what percentage of people scored more than 25 out of 50?
No, I was right there.
So, what do we have to do? What's the first thing we need to work out? Anyone? Callista?
Oh, I do have a question. So we include the person that has 25 in the.
No, I said scored more than 25. So no, you're right. We don't consider the person that got 25. Okay, Igor, what would you say we have to do?
70%.
No, but what do you have to do? I don't want an answer. I want a method.
Basically, all the ones, because there's 20, that means
So we're out of 20 people. So it's out of 20. And I need to know how many scored more than 25.
one student equals 5%, and the people who scored more than 25,
Well,
that's 14.
So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13.
13, sorry.
13 people scored more than 25. So that's 13 out of 20. Alright? So if 13 out of 20 scored more than 25, what is that as a percentage? How do we do it? Remember, Grant?
Isn't it what I said? You do 13 divided by
13 divided by 20
20.
times 100 is one way. I think what Igor probably did, another way to do it is to say if it's 13 out of 20, if I put it over 100, what would it be? So times 5. So 13 times 5 is
65.
65 over 100. So that is 65%. So it's quite a nice and easy one to do. Or, you're right, you could have done 13 divided by 20 times 100 would also give you 65.
For me, that's the easier way.
Yeah, for people. But if you don't have a calculator, for instance, you might not be able to do 13 divided by 20. Yeah, so it's worth considering other options. So my stem and leaf diagram's a mess, but who cares? I've answered the questions. But having it all lined up was nice. Okay, can I get you then, alright, to do question 5 in that exercise? Again, stem and leaf. Okay? Question 5 on stem and leaf diagram.